Okay, hello boys and girls, how are you? Welcome to the week 4 topic, fractions. Fractions are quite easy, unlike what everyone would want to make you understand. As long as you understand how to work with whole numbers, you can also get a grasp of fractions. So if you're ready, let's go. So in this topic, we're going to be looking at definitions of terms. We're going to be looking at types of fractions. We'll need to convert improper to mixed fractions. That means converting one type of fraction to the other. We're going to make it the reverse way as well, convert mixed to improper fractions. We're going to be looking at related and unrelated fractions. We're going to be looking at equivalent fractions, and we will be using it to other fractions. Should in case we are unable to use the equivalent fractions to other fractions, we will use the LCM method. We'll need to add and subtract related fractions, that's easy peasy. We'll also need to add and subtract unrelated fractions, probably make use of LCM again. And then finally, we're going to be looking at mixed fractions. All in all, it's going to be an exciting full package. So if you're ready, let's go. So the definition of terms, we want to define what a fraction is. How do we identify a number as a fraction? Look at this now. This is a typical example of a fraction where the number at the digit at top is called the numerator. The digit at top is called the numerator. There's n for short here, and the digit at the bottom is called denominator. So we have numerator over denominator. Now fractions can be of various types. We will have fractions where the numerator is smaller, like this one, and we will also have fractions where the numerator is actually larger in value. So let's continue. So talking about types of fractions, like I said, I did mention that some fractions we have the numerator smaller, and some fractions we have the numerator larger. Let's reenact this fraction. Let's bring back this fraction. We have 2 over 3. The numerator is smaller. We could also have another type of fraction, 3 over 2. Numerator is larger. These are different types of fractions. We could also have another one that has a whole number attached to it. So when the whole number is involved, it is always attached to a proper fraction. So good. So what do we call the first type of fractions where the numerator is smaller? Where the numerator is smaller, you all agree with me, it's that if you are actually larger or bigger than someone, it's normal for you to carry that person. It's actually very proper for someone who is bigger to carry someone who is smaller. So we call these proper fractions. Does that really make sense? Exactly. I will need you to understand how not to confuse these types of fractions. Based on the explanations you just heard, it's actually very proper or normal for someone who's larger to carry someone who is smaller, and that's what's happening with proper fractions. 2 over 3, good, and 3 is larger and it's carrying the 2. Let's move on to the next one. 3 over 2. This is actually very adventurous, and it is what we call improper. If it's not proper, it is improper. I am improper. Okay, these are called improper fractions, while the proper fractions that has a whole number attached to it is called a mixed fraction. Why is it mixed? You are mixing a whole number with a with a proper fraction, so that's a mixed fraction. So these 3 different types of fractions are very important. It would be good for you to rewind and replay these parts over and over again. So let's continue. So next we're talking about how to talk about how to express those improper fractions as mixed fractions. You know, we did say improper fractions are not proper, they are not expected, because a small digit is carrying a big digit. Let's look at what I'm talking about. We have another example of a proper fraction. Let's see, we have 7/2. Okay, so this is as improper as it gets. Okay, 7/2. Okay, it's like telling a 2-year-old to carry a 7-year-old. That's improper. So what do we do? I think we need to carry out a division here. Remember, we talked about division. How many 2 can I get in 3? So 7 divided by 2, basically how many 2 can I get in 3? And that's it. How many 2 can I get in 7 rather? And that's it, 3. It has a remainder of what? A remainder of 1. A remainder of 1, okay? So 7 divided by 2 is 3, remainder 1. And how do we now express this? Good. So the 3 becomes our whole number. The 3 becomes our whole number, and the 1 becomes our numerator. So it's this order. Okay, it's very, and our denominator remains the same denominator. Our denominator remains the same denominator. Okay, let's look at one more example. Let's see, we have 14 over 5. So you know the drill. Okay, do you think you can do this before I'm done solving it, or you could pause the video and solve it yourself? How many 5 can I get in 14? That's definitely 2, and it has a remainder of 4. So 2 remainder 4. So just following the format for the first example, that means we are going to have, what's our whole number going to be? Our whole number is going to be 2, and our remainder will be the numerator, while our denominator remains the same digit, 5. So with this, we have successfully expressed something that's not proper to something that's proper plus a whole number. So an improper fraction converts into a mixed fraction, that is a whole number plus a proper fraction. Essentially you can add a plus here. It's exactly what it interprets into. So you can write it this way. That's what we would expect you to write. And if you do put a plus between, you are also accurate. But this definitely is the convention. Okay? But the meaning is what I was letting you understand, that it's just an addition of the whole and the proper. That's what you get from an improper fraction. Okay, let's move on. So next on our agenda, we need to convert mixed fraction to improper fraction. Remember, we did improper to mixed initially. Now when we have a mixed fraction, let's convert to, why would someone want to convert a mixed to something that's not proper? As in, we initially did improper because we said it was not proper, it's not right. We did improper going to mixed, okay, which was acceptable because it had a proper fraction attached to a whole number. Why would we want to do the reverse? Why would we want to convert a mixed fraction that absolutely makes sense to an improper fraction? Well. Sometimes when you are working with fractions, divisions and multiplication of fractions particularly, you might need to do that. Okay, you will not be able to easily manipulate mixed fractions, but you can manipulate improper fractions very much easily. So Improper fractions don't make sense, but they make it easier to manipulate, to work with fractions. But when you don't work with fractions, definitely presenting your answers are always better in mixed fractions. Exactly. So now you understand why we need to convert mixed to improper. It helps you to carry out your calculations in fractions. Okay, good. So let's go. So I'm going to write a typical example of a mixed fraction now. Let's see, we have, remember our last answer, we had 3.5. Good. So 3, 1 over 2. How do we express this as improper? How do we convert it to an improper? Now, essentially what we need to do is this. Just pay attention. That's the whole number multiplied by your denominator, then we eventually add the numerator. We divide by your denominator again. So let's look at it. What's 3 times 2? 3 times 2 is 6. Okay, we have 6 plus 1 divided by 2. And final answer (7 over 2). Okay, good. So that settles that. Do you want one more example? Okay, you might pause the video after I write the question and quickly solve it yourself before you see the workings. So let's see if you want to express this. You want to express this mixed fraction as an improper fraction. Okay, you might need to pause your video and solve it yourself first. So I'm going to continue my own solution. So we all know that 2 times 5 is 10. Does it always have to be an addition? Yes, it always has to be an addition. And you always use the same denominator. The denominator never changes. So we already have the solution now. So that's the way it goes, that's the way it's done. So you multiply your whole number with your denominator, then you add your numerator. You divide still by the same denominator, and that's the way it's done. Okay, that's covered, that's settled. Let's move on. Well done, guys. You are almost there. You are acquiring competency working with fractions, and it's so important that you're able to work with fractions because working with fractions, working with decimals, working in percentages are an essential part of numeracy. You just cannot be lacking in those skills, and they are quite easy if you got a great tutor and if you do practice. Good. So let's move on. You are getting there. You are practically 30% done. So now we're talking about related and unrelated fractions. What are related fractions? Why should we know? We know we talked about types of fractions initially. Now, okay, this is a different level now. We want to talk about these types of topic now because we need to understand how we will approach working with fractions. If you know the kind of fraction you're working with, you know how to approach working with them. Okay, good. So related fractions, it's easier to work with them, to manipulate them, unlike unrelated fractions. So let's look at what the related fractions look like. Now, related fractions, I'm going to be writing in let's see, green. Let me write my related fractions in green now. So what are the related fractions? Look at these two fractions, pair of look at this pair of fractions. Let's say we have our 2 over 7. Okay, we also have let's say 5. I was gonna say 4 actually. 5 over 7. These are related fractions. If you have a third one to it, over 7, or you even add another 1 to it, 4 over 7. They are all related fractions. Can you pick out why they are related? Yes, exactly. They all have the same denominator, the same digit at the bottom. Okay, good. So these are related fractions. They are very, very easy to work with. You can add them easily, subtract them easily. They make sense. Okay, so these are same denominator fractions, and you will have absolutely no problem working with them. Now let's look at another type of related fractions. I'm going to use blue. Now when you look at this type of fractions, we call these green ones the same denominator fractions. Okay, they are easiest to work with. Another type of fraction, we have something like this. Let me show you. Can you see this now? Okay, good. So this is extremely easy. It's extremely easy. I'm sure by now you would have seen the relationship. Or let me give you one more. It should make it clearer to you. Okay, good. So, do you want one more? Okay, I can do that. Now, without any reason for doubt, you should know now. If you don't know, I'm going to tell you. Okay, that's why I'm here. Okay, good. So, all the denominators have something in common. They are all multiples of 7. all the denominators have something in common. They are all multiples of 7. We have 7 times 1 gives you 7. That's for the first fraction that we have there. For the second one, 7 times 3 gives you 21. For the third one, 7 times 5 gives you 35. And for the fourth one, 7 times 2 gives you 40. All these fractions are what we call related fractions. Why? Because they have denominators that are multiples of the same number. Denominators that are multiples of the same number. That is it. Denominators that are multiples of the same number, and they are related. They are also easy to manipulate, but not as easy as the first one. Same denominator fractions. Okay, these are also relatively easy. Now I'm going to show you unrelated fractions. Those ones are a bit tricky, but once you understand them, once you identify them, you have no problem. Identifying them is the issue. Once you can identify them, you have no problem. That's why I'm here. So let's identify them. Okay, good. Are you ready? Good. So I'm going to be writing them in red, or should I choose purple rather? Let's use purple. Okay, good. So let's use purple to identify unrelated fractions. Now, unrelated fractions, definitely unrelated. Let me show you. We have 2/3. Can you give you another example of a fraction that doesn't have 3 as a denominator and is not a multiple of 3? Let's say 1/4. Aha. There's no relationship between 3 and 4. Definitely, they are not the same number at the denominator, and they are not multiples of each other. Good. So that is settled. One more. Yes, exactly, one more. Seven over 10. Definitely, there's no connection between all of these. There's no connection. They are absolutely unrelated. So it doesn't necessarily have to be 4 examples. I can stay here at 3 examples, and this is exactly what we're talking about. Now you understand. The green ones are related fractions because they have the same denominator, while the blue ones are related because the denominators are multiples of a common number, while the purple ones, no connection. So okay, that is it. If you are ready now, let's move on manipulating numbers. You are ready to totally dominate fractions, to work with fractions, to add them, to subtract them, and to work with mixed fractions. Let's go. So we're talking about equivalent fractions now. Equivalent fractions. Equivalency is a very good approach to solving problems involving fractions. Equivalency makes life easy for you, and you basically use it to manipulate numbers. So let's look at what we mean by equivalent fractions now. So imagine 2/3. I love 2/3, right? Okay, because I like to make this simple. Those are small numbers. They are small numbers. I like to make this simple for you. So 2/3 now. So how do I create an equivalent fraction of 2/3? It's just basically simple. Just take your numerator, multiply it by any whole number you like. Let's say I want to multiply by 2. And take your denominator, and multiply it by the same number. The same number you're multiplying your numerator with, you multiply your denominator also by 2. So what do we have? We have 2 times 2 gives you 4. and 3 times 2 gives you 6. So what are we saying now? We are basically saying that 2 over 3 connotes the same value as 4 over 6. They mean the same thing. Giving you 2 over 3 of my money and giving you 4 over 6 of my money, it's the same thing. It's the same thing. That's why mathematicians are quite very, very intelligent. You could actually ask someone as a trick question, would you want 2 over 3 of the pizza, or would you want 4 over 6 of the pizza? And the person just looks at you. I think I will take 4 over 6. And within you, you're like, wow, you really don't know. You know, it's quite easy, the kind of things you could do when you understand numeracy. It's quite fun watching people learn from you. So 2 over 3 essentially means the same thing as 4 over 6. Okay, it's the same thing. Giving someone 2 over 3 of a pizza and giving another person 4 over 6 of a pizza, you've not done any cheating. It's the same thing. Okay, it's essentially the same thing. It doesn't stop there. You could actually multiply the numerators and the denominators by other numbers. Well, let me show you what I mean. Initially, we multiply numerator by 2. We multiply denominator also by 2. You could actually multiply by 3, by 4, by 5, by 6. Equivalency, you can use any old number to multiply your numerator and denominator, but it has to be the same number. It has to be the same number, please. Do you think you can find out 2 more equivalent fractions of 2 over 3? Yes, I can give you like 10 right now. I could tell you easily that 2 over 3, another equivalent fraction of 2 over 3 is, copying, another equivalent fraction of 2 over 3, I could tell you easily that another one is this. (20 over 30). 20 over 30 is essentially an equivalent fraction of 2 over 3. What do? We multiply numerator and denominator by 10. Numerator by 10 gives you 20. Multiply denominator by 10 gives you 30. Another one? Okay, I'm up for it. I could tell you another equivalent fraction of 2 over 3 is this. Yes, multiply by 7. 2 times 7 gives you 14, and 3 times 7 gives me 21. Remember, our original fraction was this, 2 over 3. But if I multiply 2 by 7, I get 14. If I multiply 3 also by 7, I get 21. Equivalent fraction, done and dusted. We are 45% clear. Let's move on. Now we want to order fractions. We want to tell which fraction is larger than the other. Are you ready for that? I'm going to have to finish the recording at this point when I'm done with ordering of fractions before we move on, so that the video doesn't get too exceptionally long. We're gonna have to cut it in two. Okay, good. So let's quickly order fractions, then we end this section if you're ready. So let's order the fractions. So let's look at this now. So let's order same denominator fractions. Now we are going to order same denominator fractions. Are you ready? Let's go. Same denominator fractions. Let's see. We have 2 over 7. We have 5 over 7. And we also have, say, 3 over 7, or 4 over 7. So how do we order this? How do we order it from the smallest to the largest? Now, which one do you think is number 1? Which one do you think is the smallest? Yeah, the smallest should be 2 over 7. You're right. You're very, very correct. 2 over 7 is the smallest. That's number 1. Which one is number 2? Which one is number 2? Yes, you're absolutely correct. 4 over 7 is number 2. Is the next smallest one. Is the smaller one. And then 5 over 7 is the largest. So if you're going to reorder these fractions, you have to write them this way. You will have to write them this way. You have to write them 2 over 7 first, then followed by 4 over 7, and finally 5 over 7. So this enables us to order fractions. So if they are same denominator, beautiful, it's easy for you to order. That means you have to use this. Okay, so we have 2 smaller than 4, smaller than 5. If they are the same denominator, this is the way to go. This is the way to go. Okay, good. So same denominator fractions, we've ordered them. Let's go next. Do you think we should order same numerator fractions? Let's try that. Okay, we have same numerator fractions also. Let's order same numerator fractions. Let's see how that goes. Now imagine you have 7 over 10. We have 7 over 20. And you also have 7 over 5. Remember, with the same denominator, we just have to use the numbers on top to order them, okay, from the smallest to the largest. Now, let's see. Now, how do we order these ones now? Now, which one is the smallest? Which one is the smallest? Wow. Did I hear you say 7 over 10? No. 7 over 10 is not the smallest, okay? The smallest is 7 over 5. Why is it so? I'm going to explain to you. Can you observe that 7 over 5 is actually an improper fraction? It's an improper fraction. Improper fractions are essentially larger in value than proper fractions. No matter how humongous the numbers of the proper fractions are, the digits of the proper fractions are, improper fractions are larger in value than proper fractions. So 7 over 5 is not the smallest, it's the largest. Okay, so we are going to erase that and start with the smallest. So which one do you think is the smallest? Which one do you think is the smallest now? So let's go. Which one is the smallest? The smallest definitely is 7 over 20. Why do I mean 7 over 20? Now, let me ask you a question. In a test, would you rather score 7 over 20 or 7 over 10? Definitely you prefer to score 7 over 10 and not 7 out of 20. Exactly. So 7 over 20. 7 over 20 is quite low in number. 7 over 20 is quite low in number. Good. 7 over 20 is quite low in number. No one would want to score 7 over 20 when you actually score 7 over 10. You know, 7 over 10 basically is 14 over 20. Do you understand that equivalent play there now? 7 over 10 is essentially 14 over 20, and that's definitely greater than 7 over 20, definitely. So we are not going to look at 7 over 10 as the smallest. The smallest is 7 over 20. No one wants to get 7 over 20 in a test. Yuck. Especially this intelligent bunch watching this video right now. Okay, so 7 over 20 is the smallest, followed by 7 over 10. You need to learn how to analyze. That's why I'm not saying anything else right now. There's something else I could have said, a shortcut, but you need to learn how to analyze these things, okay? There's no way I would prefer to score 7 over 20 instead of 7 over 10. Definitely 7 over 10 is better for me. So let's move on. Then the largest in value is 7 over 5. Remember what I said, that proper fractions are always larger in value than improper fractions, pardon me, are always larger in value than proper fractions. Improper fractions are always larger in value than proper fractions. There's nothing you can do about that. Improper fractions are always larger in value than proper fractions. So we've actually analyzed this now. The smallest is 7 over 20, followed by 7 over 10, and 7 over 5 is the largest in value over here. Beautiful. These are fractions that are ordered already. Do you need one more example? Okay, good. So let's look at one more example of ordering numbers. Imagine we have and this will be the final example. Okay, so imagine we have 2 over 3. We also have let's see, 1 over 4, and 3 over 5. How do we order these numbers? How do we order these numbers? Okay, what I want you to do for me is very simple. You look at the denominators. Let's look at the denominators. We have 3, we have 4, we have 5. Can we multiply those 3 numbers together? What do you think we would get? Definitely, if you multiply those 3 numbers together, you will get what? 3 times 4? 12. And 12 times 5, 60. You will get 60. So let's write 60. So what's the next step? Next step is you divide 60 by 3. That's the first denominator. Remember, divide 60 by 3, the first denominator. And what do you get? You get 20. Multiply the 20 by 2, and that gives you 40. Okay. So we have 40 here. Now the next step, you do the same thing for the second fraction. Divide 60 by 4, you get 15. Remember I taught you division. Okay, 60 divided by 4, we get 15. 15 times 1 at the top, you get 15. Still 15. So we put 15 here. And then the third one now. Divide 60 by 5, sorry. 60 by 5, divide 60 by 5, and you get 12. And 12 times 3, we all know is what? 36. So of all these numbers, which one do you think is the smallest? 15 is definitely the smallest. So 1 over 4 is the smallest fraction here. I love this method. It's called the LCM method. Okay, 1 over 4 is definitely the smallest over there. What's the next one? Because 1 over 4 is 15 over 60. What's the next one? Is 3 over 5. Why? Because 3 over 5 is 36 over 60. So 3 over 5. I'd rather score 36 over 60 than score 15 over 60. You know that, right? So we have 3 over 5. And then the best score is 40 over 60, and that is 2 over 3. Now, do you remember how I got that 60? Do you remember? I multiplied all the denominators together. 4 times 5 times 3. Exactly. 4 times 5 times 3. I got a 60. Then I divided my denominators by I divided by 60 by my denominators. Remember, how did we get 60? We did 3 times 4 times 5, and that gives us 60. How many 3 can I get in 60? That's 20. And 20 times 2 at top, that gives you 40. How many 4 in 60? That's 15. 15 times 1 at top, that gives you 15. And divided by 60 by 5, I got 12. And 12 times 3 gives me 36. And that's how I was able to create a comparison scenario for the 3 unrelated fractions. These fractions are unrelated, and you need to create a scenario for comparison by giving them a common denominator. And now the common denominator created was 60, and we were able to analyze and see that 40 over 60 is larger in value than 36 over 60, which is larger in value than 15 over 60. Hence, we have successfully ordered these fractions. Thank you for listening to this first part. When we resume on the second video, you will be watching addition and subtraction. Thank you very much.